All right, friends and family, this is 3.2, verifying properties of triangles. Anyone know what the word verify means?
Confirm.
Confirm, prove, show, demonstrate. Okay, so we're going to be using coordinate geometry to prove, show, demonstrate, verify some of the properties that we've already talked about. So we've talked about lots of properties of triangles, using medians, using right bisectors, all those kinds of things, using midpoint, using length, using slope, using area. Okay, so we're going to now take these triangles, put them on a Cartesian grid, label the vertices, give them points, and then work with that information to prove that some of the things we've been saying are actually true. So the first one you have in example 1, that's really tricky. I picked a black one and it turns out not to be black. Example 1 is dealing with triangles, is dealing with the centroid of a triangle. Centroid of a triangle. Anyone recall what a centroid is?
Where the medians intersect.
Nice, it's where the medians intersect. We knew it originally as the balancing point, but it's where the medians intersect, so you can keep that in mind. And so we're going to verify that the point C, I'm just going to put it up here because we need lots of space, 4, 0, is the centroid of the triangle. Well, you have a triangle drawn in your workbook. It doesn't have any of the points, but let's give it some points. So I'll draw it as well. We'll go over here. Something like that. We've got point Q up at the top. That has the coordinates 4, 4. O over here is at the origin, 0, 0. That's going to be interesting. And down here we have 8, negative 4. And that is point P. And what we're going to do is we're going to take the point C, and it's at 4, 0. Now your drawing is probably a little bit better than mine, but it's going to end up being right about here. I'm going to have to move my point eventually because it's not going to be perfect, but we're basically told that it is the centroid, but we have to show that. We have to prove it, okay? Well, how are we going to prove that point C is the centroid of this triangle? What do I need to do? Use the definition of a centroid to decide what you need to do. Yeah?
Use or find all the medians and then where all of them go through, put the centroid here.
So I need the point of intersection of the medians. Do I really need all 3?
Yes. Oh no, you only need
Nah, I just need 2, and I'll trust that that I did a good job. Okay. Now, okay. So if I have the point of intersection of this is only one way to do it, by the way. The point of intersection will be the centroid. Okay. There's another way to do it though, where I don't actually have to find the point of intersection. Let's call that option 1, where I just have to find equations. Find equations of the medians. And then what? If I'm not going to find the point of intersection, I already know, or I think I know, what it's going to be. How could I test whether or not this is the centroid?
Put it into the median formula.
Centroid must satisfy all 3 equations. If it does satisfy, let's talk about 2 of the equations. If it satisfies 2 of the equations, it must be the intersection of those 2 lines. There's only one point that could possibly satisfy 2 equations. It's the intersection. If it satisfies all 3 of the equations, then I've double checked already and confirmed that it's going to be the centroid. Because there's only one point that all 3 lines go through. It's the centroid. So there's only one point that will satisfy all 3 equations. It's the centroid. Okay, we're actually going to take method 2 here. Okay, so we're going to develop an equation for the median from Q, from O, and from P. And then we're going to test to see if 4, 0 satisfies those equations. If it does, it's the centroid. If it doesn't, it's not the centroid. Okay, so here we go. We need the midpoint formula. So for a median, we need to find the midpoint of, and we're only going to do this with two sides. Let's do the median from R. The median from, there is no R. Mr. V doesn't have an R. Midpoint R of side OQ. Okay, so we're going to get the median from P through OQ. Okay, I'm just going to add it to my picture even though we haven't done it yet. We're going to call that R. So that's going to be our first step. Let's find that. Step one. Find midpoint of OQ. And that looks like this. Anyone remember the midpoint formula?
M.
Okay, it's a
X,
capital M because it's a point, and it's going to be in the form XY.
X, Y.
And so now how do I actually find it?
X1 plus X2 over 2.
Yeah, it's going to be the average of my two X coordinates, so X1 plus X2 over 2, and the average of my two Y coordinates, Y1 plus Y2 over 2. Thankfully you have that memorized by now. Yeah, no, yeah, maybe, kind of.
Yes.
Okay. So here we go. I'm looking for the midpoint of OQ. So O is easy, it's 0 and 0, so I'm not even going to throw those in there. I just have, well, I'll do it, sure. 0 plus 4 over 2, and my Y coordinate is also 0 plus 4 over 2. That gives me a midpoint of, and I want to note that this is the midpoint of OQ. I can use a little subscript to keep my work organized. Also note you're going to have to do a lot of math on this page, so write smaller than you usually do.
Oh.
And 4 over 2 is 2. 4 over 2 is 2. So that tells me that point R here is at 2, 2. You can go ahead and add that to your diagram. Probably not where I added it because it's going to be in the way. 2, 2. And if you want, you can go ahead and draw that line. And what I actually need is the equation of the median. So I need the equation of the line RP. I've gotten this point. What's that going to allow me to do now between P and R? I can find the... Keep in mind I'm doing an equation of a line. What are the parts of an equation?
Well, you need to find
Slope. Okay, so next step is find the slope. Find the slope. Step 2. Find slope of RP. All right, I have 2 points. Does anyone remember my slope formula?
M lowercase equals y2 minus y1 over x2 minus x1.
Thanks. It's rise over run. So the difference in my y's, difference means subtraction, and over the difference in my x's, I'm just going to work across here for a second. Doesn't matter which point I call point 1 and point 2, as long as I'm consistent. I'm going to go with P take away R, so I've got 8 take away 2 in the top. Sorry, that's a typo. I've got negative 4 take away 2 in the top, and I have 8 take away 2 in the bottom. That's going to give me negative 6 over positive 6, which reduces to a slope of negative 1. Okay, now I have the slope of that line. I need an equation of that line. How do I develop an equation for that line?
Point slope formula.
Thank you. Develop equation for PR or RP.
Where did you get R?
It's the median. The median, RP is the median from P. Good question. Okay, I've got y minus y1 equals m times x minus x1. I've got my slope is negative 1. I can use either R or P because the line goes through both of those points, but I only need one of them, so I'm going to use R because it's got nicer numbers. On the left I have y minus 2, and in the bracket here I have x minus 2. And I'm going to use my basic algebra skills to finish this out. I'm going to do it in an extra step here. We've got y minus 2 on the left. I have negative x plus 2 on the right. And then I'm going to add 2 to both sides. Okay, some of you still making mistakes on this move. You don't get to subtract 2 from both sides. That won't do anything. You're going to add 2 to both sides, giving me y equals negative x plus 4. This is now an equation for the median RP. It's the median from P in our diagram. I'm going to leave it there, okay? And I'm going to do the same thing for a second median because it's only the centroid if this point is on 2 medians. My next step here, if I wanted to just keep going with this, is I would test whether or not 4, 0 satisfies that equation. And actually, you know what? I may as well test it right now because if it doesn't, then I don't have to carry on. I would have proven that it's false. That is not the centroid. Okay, so maybe we'll do that right now. 4. Check that C 4, 0 satisfies the equation. Okay, see if I can squeeze this in here. Left side, y. Right side, negative x plus 4. Sub in the point 4, 0. Okay, y is 0. Right side, negative x plus 4. That's negative 4 plus 4 equals 0, which equals left side. Cha-ching. So it does satisfy the equation for that median. Okay, so for our benefit, we get to do that again, and we can choose either of the remaining medians. We can do the median from O, or we can do the median from Q. It doesn't matter. Which one would you like to do?
OP.
From Q. So we're going to find the midpoint of OP. All right, and I'm not going to write my, well, I'll write my steps here. Midpoint, let's just do this. Midpoint of OQ, sorry, OP. And I'm not going to copy down my formula again because I have it right here. I'm just going to make sure I'm using the right points. We've got the average of our x coordinates. That's going to be 8 plus 0 over 2. The average of the y coordinates is going to be negative 4 plus 0 over 2. I can simplify that. I get the point 4, negative 2. That's going to be right about here. Just a quick little hope you can start noticing this. Look at what happened. It's easy from the origin. My x coordinate went from 0 to 8. The middle must be 4. Okay? My y coordinate went from 0 to negative 4. The middle must be negative 2. So this, just by looking, is going to be 4, negative 2. Because I know what midpoint means. It's the middle of my x's and the middle of my y's. And there it is. Okay, carrying on. Step 2. It's right here. We need the slope of, what are we going to name this new point? PQRS or T? T is a nice letter.
We use Z.
Let's use T.
No.
Okay, so we're going to now find the slope of QT. And I'm going to use my lowercase m and I'm going to use a subscript QT so that I know what I'm finding. Slope formula, I already wrote it down. It's right here. I can just check it. It's my change in y over my change in x. So here we go. I'm going to take my t coordinates. In the top I have negative 2 minus 4. That's the y coordinate of t minus the y coordinate of q. And in the bottom, the denominator, we have our x coordinates. I'm going to be 4 minus 4. Uh-oh.
This is problems.
Running into all sorts of trouble here.
Problems in their country.
What's going to happen here? Negative 2 minus 4 is negative 6 in the numerator. The denominator is 4 take away 4. Can I have 6 zeros
it is.
Can I-
it's an
So what is
invalid
this
number.
slope? Do you know what this slope is?
Invalid.
It runs along the y-axis.
Undefined is what I
It is
meant.
undefined. Okay? Anytime you have a 0 in the denominator, it's undefined. Okay? That's impossible. You can't split a number into zeros. You can split it into thirds, you can split it into halves, you can't split it into zeros. Okay? It's impossible. So undefined. What does that mean about our slope?
It runs on the y.
Starts with a V. The line is, yeah, this is a vertical line. So I'm going to make a little note for myself and for you and just say, here, here. Therefore, vertical line. Now, the equation of a vertical line, by the way, that means my drawing stinks. Your drawing is probably pretty good. If you draw a line from Q to T, is it perfectly vertical?
Yes. No.
Yeah.
Close but not quite perfect. Okay, so that's why we don't use pictures, we use algebra. But basically what this tells me, do you guys know the equation for a line that's vertical? What form it takes, the form for a vertical line?
Form of death.
You just write what x equals.
Yeah, x is always the same. Check out this line. It goes through T, where x is 4, and it goes through Q, where x is 4, and we're pretty sure it's going to go through C, where x is also 4. Okay?
Oh.
X is always 4. So the form for the equation of a line, a vertical line, let's just write equation of QT. It's going to take the form x equals something. And since we know that it goes through 4, -2, and it goes through 4, 4, and we have confirmed that it is actually vertical, okay, we can safely write that x equals 4 is the equation of the line QT. Yeah? Just as a total side note, if we had chosen the median from O to work with, what kind of line would we have ended up with?
Horizontal.
A horizontal line, which would have a slope of,
Perpendicular.
Zero.
0. Good job, okay? Well, this is going to get pretty easy from here. All I need to do is check that my supposed centroid satisfies this equation. Check that C at 4, 0 satisfies equation. Okay, there is no y, but I've got left side equals x, and I've got right side equals 4, and I can plug in my value for x from my centroid, right here, 4, and yep, 4 equals 4. So left side does equal right side, that checks out. All right, this point satisfies the equation for 2 of my medians. Does that make it the centroid?
Yes.
Yes. Okay, I have now verified that the point they gave me is actually the centroid. And again, this was one way to do it. Could have done it a different way too. All right, B, example 1B, it says verify. Look at that fancy word, verify.
Who likes it?
We're going to see that the centroid does something cool on this triangle, and you can go ahead and look and see if you think this is true just by looking at your diagram. Verify that the centroid will divide each median in a 2-to-1 ratio. What does that mean? Well, let's say we have a median here, and I split it up into 3 equal pieces. The centroid will be here, okay? 2 parts to 1 part. So I'm looking to see if the distance, let's say D1, I want D2 to be twice as big as D1. So I'm looking for, since I already have the centroid, it's at C, and I already have the vertices and midpoints of the opposite sides, at least for 2 of the equations. All I need to do is use my distance formula to get D1 and the distance from one point to the centroid, and then get my second distance, which would be the other endpoint to the centroid. And from that, I can see simply if it's twice as long or not. Okay? Does that make sense to you guys? That's the goal.
Yes.
I'll leave that up there. Okay, so we're going to use the length formula. We're going to take the median from PR. Well, let's use the ones that we used. Okay, I've redrawn my diagram so that we can all talk about the same things. But I've got a median going from Q to T. And we've got a median going from R to P. Okay, and there's our centroid, which was at 4, 0. Centroid 4, 0. And so I'm going to hopefully end up with the distance from R to C, from C to P, from T to C, and from Q to C. And then I'm going to look at the relationship between those distances, okay, to double check that it makes sense. Here we go. So let's do, what do you want to do? Let's do this one going across so that we don't have zeros involved. So let's split RP. And we'll use C to split RP. So we're looking for the length or distance D of RP. Okay? Copy down my distance formula. Hopefully you remember it. Sometimes I only remember the form, right? If you know the form, if you know you're doing a squared plus b squared equals c squared, then this is a good way to start with the bare bones. And what you're going to have is the difference in your x's and the difference in your y's. And again, it doesn't really matter if you do y's and x's. It's going to be the same. And now I just plug in what I know. Oh, but I lied already. I don't actually want the distance from R to P, do I?
Mistake number 2.
I want the distance, I want from R to C. Okay, here we go. I'm going to just copy this down. I'm going to plug in my R coordinates in the first spot here. So I've got 2 plus blank squared plus 2 minus blank squared. And now my C coordinates, I've got 4 and 0. All right, my first bracket, that's -2. The second bracket is +2. Look, I'm just quickly copying down the square root symbol each time. I haven't done anything with it, so I need to make sure it doesn't disappear. Okay, but I am dealing with this group underneath the radical sign. -2 squared is
4.
4, +4. 2 squared is
4.
4. So the distance here is the square root of 8. Okay? Good, good. And leave a little space because I'm going to do something a little bit tricky here, but that's okay. Leave a little space underneath there, and now we're going to get the distance from P to C, the difference of PC. I'm not going to copy down my distance formula again. All right, from PC, we've got 8 minus 4 squared plus -4 minus 0 squared. 8 minus 4 is 4. Squared is 16. Over here, we have -4 minus 0, that's -4. Squared, that's 16. Equals radical 32. Okay. Something interesting that can happen here with radicals that you guys don't know yet. So I'm just going to do it in red just to show you how this works. I can split up this radical into its factors. So I could actually rewrite this as 8 times 4. Would you agree that 32 is the same as 8 times 4?
Yeah.
Okay, so I haven't changed anything. But look at what you can do with radicals. I can now say that's radical 8 times radical 4. Okay, that's a rule that you'll start using eventually, and you'll use more and more as you move along in your Math Genius education. Now, why is this helpful? Well, what's the square root of 4? 2. So I actually have 2 times radical 8. Why is that helpful?
Because it's double.
Yeah, because my first distance was radical 8, and my second difference is clearly 2 times radical 8. Does that show a 2 to 1 ratio?
Yes.
Sure does. Okay?
But how does that make sense?
Therefore, the centroid C cuts the median RP into a 2-to-1 ratio. Do you think that will be true for the other medians?
Yes.
Yeah, it's going to be consistent. Okay, I'm going to just help you double check one of the other medians. I'm not going to do the math. I'm just going to show. We already talked about this being a vertical line. So the the x coordinates don't change at all. The only thing that changes is the y coordinate. So we're going from -2 up to 4 would be the change in y. So the distance from -2 to 4 is 6 units. Can we agree on that? Okay. Well, look at this. To get from T to C, the x coordinate again is the same because it's on that line. The y coordinate goes from -2 to 2. So this is 2 units long, and then this one, C to Q, is 4 units long. Is that a 2-to-1 ratio?
Yeah.
Sure is. 4 to 2 reduces to 2 to 1.
But
Okay.
we did all that.
And we could do the same thing over here. If we got this one, okay, this is the point 6, 0, this midpoint. This is 4, 0. Now the y coordinate's not changing. We just have to look at the x coordinate. We go from 0 to 4, and then from 4 to 6. So 0 to 4 is 4 parts. 4 to 6 is 2 parts. Is that a 2-to-1 ratio? Sure is. Okay, heading to example 2, midpoints of the sides of a triangle. So you have triangle ABC. I'm going to draw it out in the corner of my screen. Looks something like this. Yeah?
Yep.
Looks decent. I've got A,
C.
C, B. Can you give me the coordinates of A? Too slow. Coordinates of B?
Don't have it.
Too slow. Oh, you don't have them yet.
No.
Coordinates of C are 7, 5.
Mistake.
And there are more things on this diagram for me. Okay, we've got a line going like that. Is that on your diagram or no?
No.
No.
I just got a bunch on there.
All right, you can add point D, and you can add point E, and I'm going to tell you where they are. E is going to be at 6, 3. So it goes right through a graph line, a grid line. And D is at 4, 4. Okay, so we have triangle ABC. We're told that D is the midpoint of AC. So you have those markings showing that D is clearly the midpoint. And you're told that E is the midpoint of BC. So I need to add another markings, single dash on this side, to show that E is the midpoint of BC. Okay, you're told that right off the bat. Example 2, A. In A, we're going to verify that DE is parallel to AB. Okay? So what are we talking about if we're talking about parallel?
Same stuff.
We're talking about slope. Okay? So I need to find the slope of DE and the slope of AB. Okay? One of the hardest things for students in this unit is to actually do what you're talking about. Okay? So often, people are like, oh yeah, parallel, that deals with slope. Okay, I better find the length of DE. No, there's no connection between the slope of DE and the length of DE. It's irrelevant. If you need the slope, simply find the slope. Choose your formula and go for it. Okay, so I'm going to find the slope of DE. Copy down my slope formula because it's my first time doing this problem today. Change in Y over the change in X. Change markers because that marker is garbage. And for DE, plug in what I know. I've got 4 minus 3 and 4 minus 6. That's 1 over -2. which is negative 1/2. Okay, the slope of DE, I'm going to make sure I just tell myself, make sure I have a good note. This is clearly going to be the slope of DE. And now I need to find the slope of AB. So I do that off to the side. Keep your work neat and organized. Okay, keep things that you're working with together. So I already know that by the time I get down to the bottom, I'm going to have two slopes. If they're the same, it's good. If it's not, then they're not the same. Okay. Slope of AB, again, same formula. It's right there. Change in y, 3 minus 1, over change in x, 1 minus 5. Numerator, 3 minus 1 is 2. Denominator, 1 minus 5 is negative 4. Reduce, simplify, negative 1/2. Slope of AB. Okay? So that was pretty easy to find out. Now what I need to do is make a final statement. Okay? My goal was to verify that line segment DE is parallel to side AB. I'm going to say, since the slope of DE equals the slope of AB, comma, DE parallel AB. Okay? Learn that math terminology, learn those symbols and that way of writing things. You should be able to read this sentence and know exactly what it's saying. Yeah? If lines are parallel, their slope will be the same. So, if the slope is the same, lines are parallel. Okay? Since the slope of DE equals the slope of AB, DE must be parallel to AB. That was step 1. So what did we actually find out here? Well, this D is the midpoint and E is a midpoint. So we drew a line connecting two midpoints and we found out that that line is parallel to the base. That will be true always. Okay? If we had taken the midpoint here and the midpoint here and drawn a line like that, guess what? It would be parallel to this side. Yeah? That is now a property of a triangle that you know and that you can use all the time. The second property of a triangle that we're going to talk about today is, or in this example anyway, verify that line segment DE, the line segment going across from midpoint to midpoint, is half the length of AB. Does it look like it's about half the length? Okay, verify that DE equals, this is part B, 1/2 of AB. Okay, another way to write that would be AB equals 2 times DE. I'm checking for either of those. Okay, so I'm going to copy down my distance formula. Distance formula. Under the radical sign, I've got x2 minus x1 squared plus y2 minus y1 squared. All that is a squared plus b squared equals c squared. Taking the change in my run, squaring it, the change in my rise, squaring it, and then finding the square root of that. It's going to get me the hypotenuse. Okay, so let's do that. Distance for DE. For DE, here's my points. I've got my x's are 4 and 6. So I've got 4 minus 6. And my y's are 4 and 3. I've got 4 minus 3. Being consistent with which point is x1, y1, and which point is x2, y2. Then under the radical, negative 2 squared plus 1 squared. And I'm going to just finish this off. Under the radical, negative 2 squared is 4. 1 squared is 1. Are you sure it's not 2?
Yeah.
There's a 2 there, so shouldn't 1 squared be 2?
No, 1.
Like 1 times 2? Yeah, it's just 1 times 1, which is 1. 1, 1, 1. So I've got 4 plus 1, that's 5. I'm going to leave it as an exact answer under the radical, okay? I do not want a decimal. I just want it to look like this. Next step, find the distance of AB. And hopefully I get 2 times this. Let's see. Draw my radical symbol. Draw my brackets. Draw my squared. Fill in my numbers. AB. First of all, 1 minus 5. 1 minus 5. And then 3 minus 1. 3 minus 1. First bracket is negative 4 squared. Second bracket is 2 squared. Give you a second to catch up. Squared. Negative 4 squared is
16.
16.
16,
2 squared is
4,
4,
20.
now you might be saying, huh, 20 is 4 times 5. That's not twice as big, it's 4 times as big. Would that be a good way to think?
No.
No, because you're disregarding the radical symbol. Okay, we don't care what 5 and 20, what their relationship is. We want the square root of 5 and the square root of 20. So I'm going to use my little trick again. I'm going to pull a square number out of 20. Watch this. I'll do it in red again because it's so crazy. Watch this. 5 times 4. Would you agree that 20 is 5 times 4?
Yes.
Yes.
Okay. This is what you can do with radicals. That means that radical 5 times radical 4 is radical 5 times 4 is radical 20. Do you know what radical 4 is? Square root of 4?
2.
2.
2 times radical 5. Oh, that is amazing how that happened. Was it 2 to 1? Is it twice as big?
Yeah.
Yeah.
I still think that seems like
Okay.
you.
Therefore, or let's do a little since. Since the distance from AB is equal to 2 times the distance of DE, since that's true, DE is equal to 1/2 of AB. Because we came out with radical 5 for our short line, our middle line here, and radical 20, or 2 times radical 5 for our longer line, well, we know the longer line is exactly twice as long as the shorter line. Do you think that would be true for the other possibilities that we could do that in this triangle? Would always come out that, so for instance, we talked about this line right here. Do you think this line is half of this line?
Yes.
Yep. Okay, it's always going to be true. This is called the line joining 2 medians in a triangle because it's the line that joins 2 medians in a triangle. Okay? Really sophisticated wording there. So that's going to be true no matter what. So what did you learn about DE? You learned 2 things about it. About the line that joins 2 medians in a triangle. You learned that it is parallel to the opposite side. And you learn that it's half the length of the opposite side. And that will be true no matter which way we spin this triangle. Yeah? Work carefully. Use your formulas. Make sure you're verifying what you're actually trying to verify. And make sure you end with a statement that actually says what you mean it to say. Okay? Practice problems come from the worksheet that's printed in your book. Worksheet 3.2. Numbers 1 through 11. Any one of those could show up again on a quiz, a test, communications problem.